The next topic in the topic food drying and dehydration is the drying curve. What is a drying curve? Drying curve is the plot of the drying rate versus the remaining water content. Water content, say X, is expressed as kg of water per kg of dry matter. Drying process of a material can be described as a series of steps in which drying rate plays a key role. The next figure shows typical drying rate curve for a constant drying conditions. This is a typical drying rate curve where the y-axis expresses drying rate and the x-axis expresses free moisture. The process of drying starts from point A and proceeds to point B. Point A to B is known as the initial adjustment period, where the process of drying is adjusting itself to the environmental condition of the dryer. The dryer is coming up to the standard temperature and so on. The process proceeds from B to C. Now during B to C, the rate of drying becomes constant, and this is known as the constant rate period. We will further see what is the reason behind constant rate period. Now after C, the rate of drying decreases drastically till point D, and from D it further falls down to point E. So point C to E is known as the falling rate period. Point C to E is known as the falling rate period. C to D is known as the first falling rate period, and D to E is known as the second falling rate period. This is the drying rate curve, and A is the initial point. This point A to B represents the initial phase or an initial adjustment phase where the sample is being adjusted or is coming up to the standard temperature. The dryer is being adjusted to the standard temperature. The sample is coming up to the standard temperature. So A to B represents the initial adjustment phase. Now here point B represents equilibrium temperature conditions of the product surface. Section B to C of the curve is known as the constant rate period. Which represents removal of unbound water. From the product. The water acts as if the solid is not present. The surface of the product is very wet and water-like, and the water activity is equal to 1. From point B to C, in simple words, the product which is being dried acts as a free water surface, and water evaporates as if it is evaporating from a free water surface. Hence, the drying rate is constant, and this is known as constant rate period. Mind it, the water activity is equal to 1 here. During point B to C, if this is a food product, it behaves as if there is a layer of water on the surface, and hence there is continuous evaporation from the surface, and continuously water from the center is coming to the surface. This is during the constant rate period, which is B to C. Constant rate period. Next comes the falling rate period, which is from point C to point E. The falling rate period is reached when the drying rate starts to decrease. When the drying rate starts to decrease and the surface water activity falls to less than 1. The rate of drying is governed by the internal flow of liquid or vapor. This point is represented by C to E. At this point, there is not enough water on the surface to maintain a water activity value of 1. In other words, from now on, the surface of the water cannot behave as if it is a free surface of water. Suppose this is the food product. During the falling rate period, which is from C to E, the surface layer of water which was initially present is now not continuous, and most of the part of that water surface has been removed. Hence, there is a falling rate period. The falling rate period can be divided into two. The first falling rate period, which is from C to D, and from the point D to E is the second falling rate period. First falling rate period and the second falling rate period.